So in this question, it says a car can roll over if there's too much horizontal force pushing sideways on the tires. And the car pictured above is headed out of the screen towards you, turning to your left while maintaining the same speed of 20 meters per second. The centripetal acceleration is provided by an inward radial force, Fr, on the tires. If the car turns on a small enough radius, the inner tires will lift slightly off the ground, removing the normal force from the ground on those tires. Turning any smaller radius will require too much of an inward force and will flip the car. And for the first part of the question, it asks what upward force on the right tires is required to keep the acceleration in the y direction to be 0. So we know that because of the summation of forces, all the forces in the y direction must equal 0. So we can just set up 0 is equal to 9.8 times m minus f. So 9.8 times m is 9.8 times 1500, which is equal to 14,700 newtons. And these two need to cancel. So therefore, the upward force would be equal to the gravitational force on the car. Second part of the question asks what force F of R bounces the car so that the net torque equals 0. So for this part, we have to set up the sum of the torque around the center of mass to be 0. So this would take into account the upward force on the tire and the centripetal force from the turn. So 0 would have to be equal to sine times 90 minus theta, which would be the angle from the ground upwards to the direct radius from the center of mass. And this will give us, if you take the sine, this will give us the perpendicular component to the radius. So we do sine of 90 minus theta for the outside part actually here, and then minus sine of theta times the centripetal force. And if we set these equal to 0, then sine of 90 minus theta times the normal force has to equal sine times theta times centripetal force. Divide by sine of theta, and we know that theta is equal to 28.61 because we calculated it out with inverse tangent. So if we plug everything into a calculator, we know F from previous calculations. The centripetal force should turn into 26,950.5 newtons. Third part of the question asks, how could you design the car to be more stable and not tip over so easily when turning? So, if we want the car to be more stable, then we can use this equation here that we have to get a rough understanding. This question asked what is the centripetal force required for the torque to be equal to 0. So therefore, if we need more centripetal force, it should be harder to tip over the car. So if we look on top, we see the normal force and sine of 90 minus theta. If we want to increase the normal force, we can increase the mass of the car, which will make it harder to tip. We can also decrease theta so that on top, if we approach 0, 90 minus 0, then that would be 90. Sine of 90 would be equal to 1, so that would maximize the value on top, which would increase, or not increase, but maximize the centripetal force required to tip the car. And theta is the angle from the ground to the elevation over radius. So if you reduce that, the center of mass becomes lower. So that's a fancy way of saying we can lower the center of mass.